Hello friends, I welcome you in lecture number 7 on hypothesis testing. In this lecture, we are going to discuss about large sample test for difference of means or two-sample Z test. Up to lecture number 1 to 6, we have discussed about population mean and we have seen how to estimate population mean using the sample mean. So we were concerned with only one population, and we have seen how we can use sample mean to estimate population mean. So up to the lecture number 6, whatever problems we have discussed, we are given a single population and we are drawing a single sample from that given population, and depending upon the sample statistic we give inferences about population. Now from this lecture onwards we are going to compare two populations. Sometimes we require to compare two populations for certain characteristics. For example, suppose we have two populations of different methods of welding. Suppose we are discussing about two methods of welding and we want to compare that which method of welding is better in respect of their mean strengths. So in that case we will require two sample Z test. Whatever we have discussed is about single sample Z test and single sample T test. Now onwards we are going to discuss about two sample Z test and two sample T test. So if you recall, suppose we are selecting a random sample of size n from a population with mean mu and variance sigma square, then if we consider this sampling distribution of sample mean x bar, then mean of this x bar is equal to population mean and variance of the sampling distribution of mean is given by sigma square divided by n, or standard deviation is given by sigma over square root of n. Now suppose our sample size is large, we are considering n greater than or equal to 30, then central limit theorem says that if sample size is large, then this random variable x bar minus mu divided by sigma over square root of n is approximately normal, and this we consider as single sample Z statistic, and using this single sample Z statistic we find out the observed value from the given data, and then comparing with critical values of Z we draw the conclusion about the given population parameter which we have taken as population mean. Now if sample size is not large, then we are using this T distribution or T test. Instead of Z we write T here, and we use the sample standard deviation if population standard deviation is not given with certain degrees of freedom, which is equal to sample size minus 1. So we have discussed all these things up to lecture number 6. If we have a single sample and if we are interested in the hypothesis testing for a population mean, then for large sample we are using Z statistic or Z test, and for small samples we are considering T test, and the sample size greater than or equal to 30 we consider as large sample, and if n is less than 30 we consider that sample as small sample. So this is what we have discussed up to lecture number 6. We have discussed how to estimate or how to test the hypothesis about population mean using sample statistic, either Z statistic or T statistics. Now onwards, our focus is on comparing two populations. Suppose we are interested in the comparison between two populations, then we have to apply TwoSample Z test and TwoSample T test. So suppose we have two populations, say population 1 and population 2. Suppose population 1 has mean mu1 and population 2 has mean mu2. Similarly, suppose variance of population 1 is denoted by sigma 1 square and variance of population 2 is denoted by sigma 2 square, and we want to check whether there is any significant difference between the population means. That is, we want to check whether this mu1, that is mean of population 1, and mu2, that is mean of population 2, are equal or whether they are different from each other. So for this type of testing, we have to consider another distribution, which is the distribution of difference of means. Suppose we are considering a random sample of size n1, suppose x1 x2 up to xn1 is a random sample of size n1 from population 1, and say y1 y2 up to yn2 is a random sample of size n2 from population 2, and suppose we want to test whether there is any significant difference between the population means of given two populations whose mean are mu1 and mu2 and variance or standard deviations are sigma 1 and sigma 2. Then how to test this hypothesis? This is null hypothesis and this is alternative hypothesis. So for that we have to apply TwoSample Z test. But before applying that TwoSample Z test, we have to make some assumptions. First assumption is that we are considering these samples randomly from given populations. Second assumption is that these two samples are independent of each other. We must be clear that there is no relationship between the samples which we are drawing from two populations. They are independent of each other. And third assumption is that both the populations follow normal distribution. So we are considering the underlying populations as normal populations. So under these assumptions, we want to check this, or we want to test this null hypothesis mu1 equal to mu2. So what will be the corresponding test statistic for this? So if you recall, if we have sample size large, that is n greater than or equal to 30, then we know that this z equal to x bar minus mu divided by sigma over square root of n is z statistic for testing single mean or single population mean. Here our hypothesis is mu equal to some value. So this is what we have discussed up to lecture number 6. If we have a single population and if we have a sample which is large enough, and if we are given population mean mu and standard deviation sigma, then this z given by this formula x bar minus mu divided by sigma over square root of n is approximately normal. This is by central limit theorem. So same result we have to discuss for the difference of means. So in that case we have to first consider the sampling distribution of the difference between x bar and y bar. X bar is the sampling distribution of first sample and y bar is for second sample. So suppose we are concerned about this x bar minus y bar, then the corresponding test statistic is, so here instead of x I have to write x bar minus y bar. Here my null hypothesis will be mu1 equal to mu2, that I can write as mu1 minus mu2 equal to 0. So here or some value, say delta. So here we are, instead of mu we have difference of these two population means mu1 and mu2, and if you observe this I can rewrite as sigma square divided by n and square root of this. So here equivalent to this, here I have two populations, so I have two population variances. For first population we have sigma 1 square divided by size of first sample, that is n1, sigma 2 square divided by n2. So we can prove that if we define z in this way, which is analogous to this, you don't have to remember this formula, you just remember this formula, and here instead of sampling distribution of x bar we have sampling distribution of x bar minus y bar. So we replace x bar by x bar minus y bar, we replace mu by difference between mu1 and mu2, and here we have only one population, so we have sigma square divided by n, and here I have sigma 1 square over n1 plus sigma 2 square over n2. So if we consider n1 and n2, if sample sizes are greater than or equal to 30, then this z statistic is standardized normal random variable, and we can use this TwoSample Z test to check or to test the difference between two means. So this is TwoSample Z test. Now sometimes suppose we are not given this population variances, then we can replace this sigma 1 square by sample standard deviation s1 square and sigma 2 square by sample standard deviation for second sample s2 square. So we will remember this TwoSample Z test, and using this TwoSample Z test we can test that whether there is any significant difference between the population means of two populations, or we can compare two populations with respect to their population means. Now suppose sample size is less than 30, then instead of Z test we will apply T test, but that we will discuss after we discuss some problems related to this TwoSample Z test. And we can derive this formula also using central limit theorem, but here it is not necessary to prove this formula, so I am not going into the details that how this formula is coming. We will just remember this TwoSample Z test, and we will also remember that here we have three assumptions that we are considering random samples. So x1, x2, xn1 is a random sample of size n1 from population 1 with mean mu1 and variance sigma 1 square. Second assumption is y1, y2, yn2 is also a random sample of size n2 from population 2 which has mean mu2 and variance sigma 2 square, and this is also required that the two samples are independent. So if these three assumptions are satisfied, then if sample sizes are large enough, that is n1 and n2 are greater than or equal to 30, this z equal to x bar minus y bar minus mu1 minus mu2 divided by square root of sigma 1 square over n1 plus sigma 2 square over n2 is approximately standard normal random variable. And we make the remark that if population variances are not given, then we can replace them by sample variances denoted by s1 square and s2 square. So this is two sample Z test, and remember it is analogous to this one sample Z test, which was x bar minus mu divided by sigma over square root of n. Instead of x bar I have x bar minus y bar. So again I write, it is easy to remember, replace x bar by x bar minus y bar. Here this mu is replaced by mu1 minus mu2. This quantity is equivalent to sigma 1 square over n1 plus sigma 2 square over n2, and this is two sample Z test provided n1 and n2 both are greater than or equal to 30. Two samples drawn are random and they are independent. Independent samples are required. In the beginning of this lecture I said that populations must be normal, but that is not required here. For t test we will require that underlying populations are normal, but for Z test it is not necessary that the populations which we are drawing must follow a normal distribution. They can be any distributions, but if sample sizes are large, then this Z defined in this way will be a standard normal random variable. So this is all about this lecture. Here we have discussed how we can apply two sample Z test to test that whether there is any significant difference between the two population means. That is, we are testing the differences of population means, and if sample sizes are greater than or equal to 30 for the samples which we will draw from given populations, then we can apply two sample Z test. So in the next lecture we will discuss problems related to two sample Z test. So I hope you like this lecture. Thanks for watching.